Hi, this is Mr. Ferris, and I'm going to try to explain R squared using a demonstration from a data set I collected in class. So the story behind this might be that I am going to give several students a chance to grab a handful of starbursts out of a bucket, but I would like to kind of know how many starbursts I should buy first so that I have enough for, say, maybe 5 students to reach in and grab starbursts. So I collect a preliminary set of data. 18 students grabbed some starbursts, and this was what they got. Everything from the mid-teens to the mid-40s. I could measure the standard deviation. I can certainly see the deviation. I can see the range is like 30. So it seems like maybe this has a lot of variation and it would be a little hard to figure out. I could, I suppose, go with the mean of 26.5 and just say, all right, it's going to be five times that would be a good estimate. But since there's so much variation, I might overestimate or underestimate by quite a bit. So instead, maybe I should bring an explanatory variable into the mix. Like, for instance, hand span. If you measure the distance from the tip of the thumb to the tip of the pinky, which might be the diameter of your hand or the hand span, then we can see that there's definitely a positive and kind of moderately strong linear association between those two. And a linear model might actually help me to predict more accurately how many starbursts I should have, especially if maybe I could measure the kids' hands ahead of time. If I could measure those 5 kids' hands ahead of time, then maybe I could do a better job of predicting. And here's why. Let's go back and think about the amount of variation. The range is about 30. We could calculate the standard deviation. We could calculate variance. Those are all measures of variation. But let me introduce you to another measure of variation called sum of squares total. The sum of squares total is essentially the numerator of the variance before you divide by n minus 1. Or another way of showing you, if you find the distance between each data point and the mean, and then square that and add them all up, that would be the sum of the squares total. One way to do this electronically is to put starbursts on the y-axis and then graph the mean of those. I have to add handspan just to do this with my technology. So I've taken this 26.5, graphed it horizontally now, and calculated basically the residuals and then squared them and added them up. So the sum of squares total is 1,306. That's a measure of the total variation in the starburst data set. If I do the same sort of thing with a scatter plot using handspan as the explanatory variable and starburst as the response variable, I find out that I can calculate this same calculation of the squares of the residuals and add them all up. In other words, how far away we are from this line instead of the horizontal mean line. I find out that the sum of squares in this scenario is way less. I started out with 1,306 doing the sum of squares from the mean of starbursts, but if I add an explanatory variable and use a linear model and do the same sort of calculation, I have eliminated quite a bit of that variation, more than half. If I calculate it exactly, I've eliminated, or you could even say accounted for or explained, 850 of that original 1,306 is basically gone. If you calculate the percent that's gone, it turns out to be about 65%. More than half of that 1,306 has been explained by using a linear model on handspan. Well, looky here. There's R squared right there. 65%, that's what it is. R squared is the percent of the total variation that we started with that can be explained or accounted for, or in this case, really eliminated. I mean, it's gone now. It's not there anymore by putting a linear model on an explanatory variable handspan. So when we say that definition from our textbook, it might make a little more sense in a real case like this. And when you think about it, not all the variation can be attributed to handspan. There's other variations, like maybe the depth of your hand as you grab, there's like this three-dimensional depth. Maybe that measurement can account for some of the variation. Maybe the height of your hand from top to bottom can also account for some of the variation. So there are other sources of variation that could be contributing to the variation in starburst. So it makes a lot of sense when you think about it in those terms, and when you get to college, you'll actually be able to do something called multiple regression, where you can have more than one explanatory variable and more than one R-squared. But for now, that is just a little background on where R-squared comes from. You will not have to know this for the AP exam. This is just a little deeper mathematical background just to give you a little understanding. So I hope that helped a little bit.